Okay. So we're going to try something here on our script. I looked into this a little bit. So right now we're trying to get that baby to stop moving when we let go of the key, and we still are having a little bit of a slide effect. So I'm going to try to turn off, when we did set the velocity to 0 before, but I'm going to try to turn off something called angular velocity as well. So, and I think that's the force that's making the baby continue to move. The question is, do we just have to do it once, or because of the cumulative effect of add force, do we need to flag that the key has not been pressed and make sure we continually set it to 0? So we'll have to look at that here for the next few minutes. I mean, the difference is an if statement, but it is also a performance difference where we're checking that every single, whether it's frame or we do it in fixed update. Okay, so right here, where we are getting the key up for our right arrow, we're going to go ahead and we're going to, this is where we set the velocity of our rigid body. Now I'm going to say this dot RB dot angular velocity is equal to vector 2 dot 0. So here's an alternative way. Oh, it wants so angular velocity is a float, not a vector. Yeah, that's a float. So we're actually going to set that equal to 0f or 9f, whatever. There you go, 0f. So we'll turn off velocity and we'll turn off angular velocity. And I thought they were both vector 2s here. The thing I was looking at. Nope. Well, they were in that, but so let's see what that does just as the, so we're going to do this one time on the moment that our right arrow is released. And let's actually add our inverse force first, even though I think we saw last time that these guys are, they're directive, so they're not necessarily happening in an order. They're things that are getting sent to the rigid body. They should mostly happen in the order because those messages are being sent in the order, but if one of those directives takes longer than another, they're happening in multiple threads, so they can't happen seemingly independent of each other. All right, so let's see if this makes any sort of difference on our stopping motion. Okay, so that did not seem to make a difference, I would say, on the movement. So now let me what we're going to do is we are going to flag when this right key was up. And once we put it back down, then we're going to unflag it. And what I mean by flag it, so we're going to have a private variable, and it's going to be a Boolean. So we're going to call this right arrow up. And by default, this is going to be true. When the game first starts, we have not let go of the right arrow. Well, the right arrow is currently in an up position. We haven't pressed it. So then down here, when we do the key up for right arrow, we'll say this dot right arrow up is equal to true. So we're going to flip it back to true. And I did do true up here, yep. Otherwise, in this else here, that means that one of those keys is pressed down, correct? So we don't want it to be going to a stop. We'll add the left arrow here in a second. But so we're going to say this dot right arrow up is equal to false because one of the keys is being pressed. Really what we can probably do is replace right arrow with just arrow up because we want it to come to a stop regardless of whether it's the left or the right that we were moving. But right now we only have a right arrow. So what we'll do is we'll initially set, actually my feeling here is if I comment these two out, we probably will not see a difference in performance. I doubt it'll seem any different because we're just applying it once before the cumulative of force catches up. No, it definitely had a difference. Oh, and that's because our inverse force on the baby was different, and this is based on that guy, right? Because we were building up that force to push back. Let's see that here. Yeah, so now we had a cumulative. Oh, we need to zero back out. So after we apply that force, that horizontal force, we need to, this guy's a vector too, so let me show you the thing I was trying to show you before. So we can create a new vector 2, passing it a 0, 0, like we did right here. There's also a shorthand for that. It's called vector 2.0. So this guy right here is the same as creating a brand new vector whose x and y is 0 and 0. So vector 2.0. Choose the one you like using. Technically, this one would be the better one to use because it's not creating brand new memory. When we say new vector right here, we're creating a brand new vector that is taking up another spot in memory. Where really this is like saying the constant 0. The literal 0, we just happen to have the constant that is the vector 2 with 0, 0 for the x and y. All right, so this will undo that horizontal force. Let's make sure that that behaves the way we want it to behave each time. And then we're going to look at late update for those velocity things. Okay, that seemed fine. That seemed mostly fine. We're getting a little pushback. So it seems like we're probably getting that one last force. That's why the baby's kind of getting shoved back. So we probably can come in here and do minus. We won't have movement at that point. What happened if we turned off that opposite force and just set the velocities? I think we tried that last time. So rather than a pushback force where we like throw a wall in front of him, we just turn his velocity to 0, ignoring that we're still going to have a cumulative force. All right, so that seems to give us the move that we want. Still having the slide effect, but you know it's where we are hitting the brakes. So now what we're going to do is we're going to go into our script, and we're going to add another function in here called late update. And I think I mentioned late update before, right? Does that sound, what does late update do? What's the purpose of that guy? When will we use late update? Or what's the maybe when will we use it? It's the wrong question because it's going to be kind of situational, but what are the characteristics of late update? So what were the characteristics of update? Update gets called every single frame, right? What are the characteristics of fixed update? 60 frames a second-ish type. It tries to mimic 60 frames a second. What's the characteristic then of late update? Why do we need all these different updates for pulling off stuff in our game? What does its name imply? That this guy happens late. It's called last and also with lowest priority. So, you know, when we start stuffing a whole bunch of stuff into our various updates, if they start taking time and we've already moved on to the next frame, late update will either get skipped or be called with the lowest priority. So we only want to put stuff in here that you know, we would love for it to happen on a per frame basis, but if it gets skipped for one frame, we're going to say that's not the end of the world. We'll have to decide whether that's the case here. So now what I'm going to do is I'm going to just say if the right arrow is currently up, so this is operating off this flag approach, keeping track of what the current state of our buttons are. The right arrow is currently up. We're going to go ahead and we're going to set, I'm going to use that vector 2.0 thing. We'll set the velocity of our rigid body equal to 0 and the angular velocity equal to 0. So the hope is, well, really there's two things here. We have that cumulative effect of our add force that's still, you know, winding down. And we know that that's going to be higher priority than the stuff that's happening inside of late update. So that force should have already occurred, that updated force. And now we're going to zero out the velocity again. And let's see if this either completely hits the brakes or at least looks like it's slowing down more. Because now we're going to continue that motion. It didn't really do it. So then let me do it on the velocity. So rather than keeping track of the right arrow up, I'm going to ask a different question here. So we're looking at like magic tricks we can use to simulate a behavior. So I'm going to say if this dot rigid body I called it RB, right? This dot RB dot velocity dot magnitude. So this this gets me just the x velocity. So that's a vector 2 velocity. This is going to get me the x on it. And we're going to say if this guy is less than, to make it a really small number, because really we're saying if he's almost stopped, stop him. So let's try something like 0.01 f. So if the magnitude is very low, hit the brakes. So this will operate off of less of the key, keeping track of whether the key has been pressed or not, and more off of how fast the dude is currently moving. Let's see what kind of behavior this gives us. Let's increase that number a little bit. Let's go something like 0.1. Yeah, he still has that slide effect. So the issue is somewhere in there, there's going to be that balance between if we put too much force in the opposite direction, he's going to, what if we, because when we apply a force, we can apply a force that's equal to the velocity, right? Because the force we add is so let's dump this late update. That didn't seem to make a difference. When we add a force, we are adding so I'm going to do this. This dot RB dot velocity times -1. So I'm going to add a force that is the inverse of his current velocity rather than the accumulated. And I'm pretty sure we tried this last time. I don't think it gave us a real benefit. So if this doesn't do it, we'll just say our guy slides a little bit. Yeah, it didn't actually do it at all because his current velocity, how fast he's moving that exact frame isn't equal to the force that it takes to slow him down. So because that's not a force, force and a speed are different. Yeah. Looks like the most we can do is, if we want to make this as simple as possible, we're going to forget about this right arrow up thing. And we're going to say in our game, you do have to hit the brakes. Unless somebody has a better solution. You have a better solution?
I did player rigid body dot velocity equals a new vector 2 multiplied by the move of the input. Or with the move of the input multiplied by the max speed that I set to 10F.
So that's max speed is what? That's not this value.
I set it to 10F. It's different.
Okay.
The move is the actual input from the axis.
Okay. So we would need to put that value up top.
Yeah.
To give us access to it.
Well, actually, no. I'll just show you. You do that way.
Well, you're getting this value.
Yes.
But right now we're just getting in the L, so you have to get it at the top.
I'm getting it here, and I'm setting the max speed to 10F, and then the rigid body velocity, new vector 2, move times the max speed, and then I'm doing the rigid body velocity on Y.
Okay, which is that's on up. That's going up.
Yeah. And in game, it looks like this.
Okay, so tiny slide, but less of a slide. Well, at that speed, it's not anything. But if you want faster, there is a little bit of a slide to a stop, but way more muted than ours.
Yeah.
But does the math actually make any sense, or is it just a parlor trick? You see what I'm saying? Yeah, it's
I don't know.
Kind of like your numbers happen to work. But
I got my numbers from Unity, so.
Oh, you found like something on like a forum that said this is try this?
Yeah.
It's interesting. Go ahead.
Mine doesn't have slides because once you press it once, it won't count as you continuously pressing it.
Yeah.
But once you lift up, it'll like take note that you lifted up. And since it only ended with it once, it just has to remove it once.
Oh, so you're not adding force.
I'm not adding force. It's added once and then just kept there as long as the button is down.
Gotcha. So you're not adding force each time, but you are adding force the first time.
Yes.
So you're adding initial force. Okay.
I have a string that is like checking to see if you've already added.
Right, but then you would have to make sure there's no drag.
Yeah.
Because this is kind of like a vacuum of space, right? If you push something in space, then it just starts, because it's in a vacuum, it just goes, and it's and if you keep applying a force, it accelerates. Isn't this kind of the some of the idea that NASA has for like high speed space travel? Is they don't need a really powerful booster, they just need time. So they apply a constant, call it low force, to the shuttle that's in whatever is flying in space, and it just start. Am I dictating this? I'm dictating this. Who's this? Space travel is they don't. Very nice. That's interesting that I triggered that. So it just keeps accumulating that force until the thing's going zillions of miles an hour. And I think they've even tried to do something with like solar winds to accomplish the same thing, where it's actually a renewable. You don't have to use any fuel. We're just like, look, we'll take 3 days, but at the end of 3 days, we're going super, super fast. And then they just saved their fuel for slowing down at the end. So kind of an interesting thing. So that's how the adding force once would work. Otherwise, you're going to have slowdown from the he's not in a vacuum type situation. Okay. Well, just to keep our thing simple here, in my mind, I want to say that those things are kind of parlor tricks, but at the same time, they might be the necessary parlor trick to pull it off, because we are dealing with simulated physics. The math works out, but we have an auto mass of this guy and that kind of stuff. So why don't we just say in our game here, if you want to really hit the brakes, you turn back the other direction, which I think is usually the way you do it anyways, right? So we'll just call that good. So in this case, we will set the velocity. The right arrow is pressed up. We're going to go ahead and set the velocity to 0. We'll set the angular velocity also to 0, although I'm not sure I necessarily saw a difference there. I'll go ahead and dump that. I already took it out. My Boolean variable up there. But it at least allowed us to. So a Boolean variable like that is often referred to as a flag. So if you're ever looking at documentation, flag, on, off, true, false, those guys are often called flags. Okay. So if get key up, we'll turn the velocity off for the time being, knowing there's going to be some additional force. Otherwise, we're going to, and really we want to say if the right arrow is up, or input.key up key code dot left arrow. So if either of those keys have been pressed up, let's hit the brakes. And even with that, we can probably sit there and come up with some, it's like, well, what if they lift both of them at the same time, or stuff like that, and you get weird movement. So what's the punchline of all of this, without us spending more class time on it, is player movement, while it's very important, is also kind of and maybe this is why you see player movement working a little bit different in different games. It's kind of a trick. What makes the most sense for that game? Obviously, in a 3D game, you have different forces working on you. And one thing we can do here is, and this would probably be the real fix, and this is along the lines of what Gabe was suggesting, is avoid using add force and instead translate the transform. So we have this, so different, we can scale a transform. We can also translate a transform. Translate says, go from here to here, change its position. So if we just keep changing its position each frame, and because that's our minimal opportunity for something to update on the screen is per frame, right? If we say he's here in this frame, 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 and then we just don't move him when the key is pressed up, that should give us the effect that he was getting without maybe well, I mean, it's not really fair to say the parlor trick, but without the effect of having to deal with a vacuum. Because now we're not relying on the cumulative effect of a force. We are physically moving our guy it's like a flip book. Okay, we're moving him here, 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 here. So that if we want him to stop moving, we just don't move him the next frame. Does that make sense? There isn't a force being applied. So we could pull it off that way as well. Although, as you might imagine, there might be some performance issues to that as our game gets more and more complex. Realistically speaking, if you are running a 2D game on a modern desktop or laptop computer, you would probably really have to try to get a performance impact. But certainly when we take it over to a mobile device, we can start running into issues. So, what are our mobile devices? They're probably about as fast as our computers were, call it 7-8 years ago. Something in that ballpark. So they keep getting faster and faster, but certainly we're going to be able to fight the performance resources of this more quickly than we will on a more of a desktop class machine. So different approaches to this, but as we can see, if you have 3 different games, you're probably going to have 3 different movement styles, even though they might be a little bit similar. And when you first play a game, isn't that something you kind of get used to? Is how does movement kind of work? So we'll just leave it at that for our movement and say that our baby skids to a stop unless you turn back the other direction and apply that balancing force. Okay, so with that in mind, let's go ahead and get some animations here on the baby. We've been promising that for several classes, so let's just do it. Okay, so what we want to happen here is as our baby is moving to the right. So right now we have this idle animation on our baby, right? So kind of reminding us we had we have our animator on the baby, and we created a couple of different animations. I think we have a running animation and we have an idle animation, and we saw the 2 of those. Let's just flip back real quick and show that. So here's our animator. Actually, let's click on the player first. Here's the animator associated with the guy I have selected, which is my player. And we have 2 different animations that we created. One's called the Zombie Baby Idle, which is the one that's playing right now. So on entry, Zombie Baby Idle displays. Now, to see what running looks like, we'll go ahead and set that guy as the default layer. So I just right-clicked on it and said, now he's the default. So now our baby should be constantly in his running animation. Look at that. That has a real, a little bit fast probably, but a real zombie type of look. Right? Yeah, it's perfect. Okay, so in any case, what we'd really like to do is we want to transition between that idle when he's standing still and that running when he's moving, right? So we're going to need effectively a flag, but now we have a third name for it, a trigger that works with the animator. So I'm going to switch back and have idle playing by default. And then before I do anything else in here, I'm going to come up here to the left, and we have these things called parameters. All right, and I'm going to create, I have a little plus sign here, I'm going to create a parameter, and this guy's going to be of type trigger. And we're going to call this should run. I'm going to create another trigger called should idle. Should idle. Okay. So these 2 triggers indicate events that we want to occur for a transition between animations. So right now when the game starts, there is no transition. I guess technically this is a transition. Game starts, we transition to the default animation, which we've selected as idle. Now, we want to create a condition by which we move from idle to running. Okay, so I'm going to right click on idle. It's going to give us this pop up. We're going to make a transition, and we'll just come down to our running transition, let go of that. And then we're going to click this transition itself. And then over here in the inspector for this transition, we have some conditions. Now, I think, didn't we turn off exit time? I think we did that in here, right? Or a difference between the animations. Well, we'll look at it here in a second. That might have been in a different class. But in any case, if I go to conditions, should run is when we transition from idle to running. That's the event that needs to occur in order for that transition to occur. All right, so just one condition in here. Similarly, I'm going to right click on running. We're going to make a transition back to idle. I'll click on that transition, and we want this guy to only occur when should idle gets turned on. Okay. So let's go ahead and go back to our code. Now, again, just as a reminder, here's our player. Our player has all this stuff associated with it, but the important thing for us right now is this thing called an animator. Okay, and remember, animators have animator controllers associated with it, and what we were just messing with here is our visualization of that controller. Okay, this is just a state machine that says under what circumstances is what animation playing. Okay, we come in as idle. Now we're allowed to transition to running and transition back to idle. That's the, that's the states we've created. Now we need to create the logic that actually makes that transition. So now we need to remember the names of these triggers. So we have should run with a capital R and should idle with a capital I. Go into our script. Now, when we start running, so inside this else, when we're grabbing the movement, this is when we want that run animation to start. Correct? Now, in order to do that, we need to get access to the animator for this rigid body. So we're going to go ahead, we're going to create a private variable up here. So private animator. We'll call this guy anim. And then inside of start, which only gets called one time when this script first launches, we're going to say this dot anim is equal to this, which is the zombie baby, dot get component. The component we want is the animator component of that baby. So that gives us convenient access to that animator rather than having to say this dot get component animator every single time we want to use it. Does that make sense? This is not required. This is just giving us a variable to conveniently access the animator. Otherwise, we could call this line right here every single time we want to do something with the animator, which is going to get old pretty quick. Okay. So now down here in our else, when we're actually, this is when we're calculating movement either left or right. We're going to go ahead and say this dot anim dot set trigger, and we give it a string for the trigger that we want. So we're going to say should run. And that'll set the run trigger. Similarly, if we have pressed the arrow key up, we'll say this dot anim dot set trigger should idle. All right, so we set it up inside the controller, and now we're using our code to send the trigger to the animator so that that animation, I think it's called the animation controller. The animation controller moves into the correct state. Okay, takes the correct transitions based on the current triggers. All right, and we'll also eventually have an animation here for jump. So go ahead and save this. Go ahead and run our game. Starts off as idle. When I start moving, baby starts moving, or starts running. Okay, now something we see here is, so baby's idle right now. And actually what we did, we just saw some catch up. He's running right now, right? Even though I haven't pressed it. Okay, these animations have an amount of time associated with them. So actually I'm surprised he's Still running. Is that just from going back and forth so many times? Or was that just the last state we were in? We tricked it. Okay. In any case, even though these are very short animations, I think when we picked the frames, they were like two or three pictures or something like that. They do have an amount of time. And we can imagine that when I change directions quickly, the transition between those is he's still idle for a moment while we start going. We'll really want the baby to immediately exit the current animation and move into the next animation. So we're going to stop this, and we're going to go into our animator for that player. We're going to click on that idle. Actually, we're going to click on the transition between the idle and the running. And we have this button called Has Exit Time. Okay, and let me click on settings real quick to make sure there's not something else that's in there. Yeah, I think it's Has Exit Time we have to use. So Has Exit Time says that it turns off the finish to the end of the animation. I think this is the control we use for this. So that means as soon as we make that transition, we start the next animation. We don't wait for this guy to finish. Similarly, we'll do it on the transition coming back. We'll turn off Has Exit Time. And then I believe, assuming that was the right flag, I'm pretty sure it is. It's actually interesting. The baby landed. Why is he already running? Oh, he's already running because the default is to make him run regardless of whether or not we actually press movement, because this is in the else. So as soon as he lands, he starts running even though he hasn't actually started moving. So we really need to have this should running based on our movement being something greater than 0, let's say. If movement, let's move horizontal. Is greater than, I think it'll be 0 by 00F. Then we're going to go ahead and tell him to start running. So if he's actually trying to move, make him look like he's moving. I think move horizontal, we had printed that statement out before, and I think it always goes back to 0 when we let go of the key. Is that for some reason I thought it had values larger than that, but let's see here real quick. Okay, baby lands. Now we'll start moving. There's his run. He's idle again. Running again. Turbo moonwalk, baby. Now, I believe in Mario does why is he going backwards again? Was he still sliding? I think we might need to not quite do it to 0. Maybe make it greater than 0.1. Oh, when he's going backwards, I think it's a negative number, isn't it? Let's just print out move horizontal. I'm pretty sure it's a negative number when he's going backwards. So we'll print move horizontal. Click our console on here. So there's a whole bunch of zeros. Now it's a positive number back to 0. Now it's a negative number back to 0. Well, so it does go to 0. I think we can operate off the 0 value. And just call that close enough. So we're going to call this guy 0f. But what we're going to do here is we're going to get the absolute value of move horizontal, because sometimes it is negative, right? Although, let's do this. If move horizontal is not equal to 0, okay, or we could just use a not equal. This says the same thing. So if it's negative or positive, he's going to be running. If it's not equal to 0, if it is equal to 0, we're going to keep it at the, whatever it used to be, which is, in our case right now, idle. So this should fix the move backwards issue. That's interesting that he's it's at 0 right now. So I think because this guy's only getting called so often, we probably need to throw the else on here, at least to give us the effect that we want. So we'll set it to idle as an alternative. So if it's anything but 0, go to should run, otherwise should idle. This is really going to be somewhat inefficient internally, because now we're flipping animations relatively quickly. Yeah, you kind of saw that when the baby's like sliding. You see how he starts running just a little bit and then stops running. So we'll call that close enough. Okay. Now we want to give ourselves a jump animation, and then we'll make it so that because right now I think we still have our double jump ability, right? So baby can just fly over all the enemies. Which, I mean, obviously most zombie babies do fly, so it's that is a little bit true to life. And let's go ahead and take out this this print statement. Now we've seen the behavior of that. Okay, so let's actually fix the double jump first. Then we'll, well, I don't know. Since we're doing animations right now, let's go ahead and fix the add our animation for our baby jumping. So we'll come back in here. We're going to go to our project. We're going to go to our assets. Go to our, well, that's our animation folder. We need our pixel textures. Actually, it wasn't textures. That was for the sheet. Characters. This is the guy we want. All right, so we need to look at which ones are for the jump. And I think we had kind of decided there's a little, like a punch the air type thing, right? Right there, that guy. Okay, so it's those two frames that will give us the jump animation. So I just highlighted those two. I'll go ahead and drag it into the scene. It's going to ask for the new animation. We're going to call this baby jump, even though now we're just breaking naming conventions. Put this into our animations here. Baby zombie jumping. I guess we already weren't real consistent. All right, so that's going to be the name of that animation we just created. All right, now we can go ahead and remove that guy. So the way we created the animation, the easiest way to create the animation is to select the things you want, drag it into the screen, it automatically generates an animation for you. So we'll delete that from our scene right now, but now inside of our animations folder, we have a new animation. Now, this controller was also created. So a byproduct of our creating a new animation also generates a new controller. We don't want a new controller for this animation, right? We have a controller that we're using for all of our transitions, so we can go ahead and delete that new controller that was created. Don't delete the new animation, which is this guy. All right, so I'll delete the new controller. And then we're going to go to our original controller, and we'll go ahead and drag the jumping animation in here. Is it dying? Oh, no, I guess you... Can I really not move this around? That's very interesting. Can you move your animations around? Yeah.
I've never seen that before.
Oh, well, whatever. I mean, it seems like it's responsive otherwise. All right, so I'm going to go ahead. We're going to go ahead and create a parameter here first. So we're going to create another trigger, and this trigger is going to be should jump. All right, should jump trigger. Now we're going to create a transition between should idle, or between the baby idle and the jumping, and we'll go ahead and add a condition to this. The condition is going to be should jump, and then go ahead and turn off the exit time. Then we're going to add a transition from jumping back to idle. Click on that transition. Make sure you click the right transition. We'll turn off exit time. We'll go to the conditions, and this is should idle. So if we're currently jumping and we should go back to idle, we'll have to consider when that should happen here in a second. We'll transition back to idle. If we are currently running and we should jump, we're going to make a transition to jumping. Oh, there, I can move it now. Very interesting. It's like arthritis. You need to just do a couple transitions to loosen them up in the morning. All right, so we'll click on that transition here. So we go from running to jumping if the trigger should jump is fired. Kind of see the benefit of using these triggers? We can just pretty cleanly say no matter what transition, or no matter what state I'm currently in, to go to the jumping state requires the trigger of should jump. So then we can always just set those triggers in code, and whatever state he's currently in, he moves to the next state. It won't always work like this, because sometimes, like for instance, we might want to have a walk versus run animation, and we might want to do that based on the current float value of speed or something like that, where we maybe update the speed value of our animator each time on update or something, and that animation will then automatically transition depending on the speed the baby's currently moving. That might be something we would want to do, but right now let's just stick with triggers. So we move from running to jumping if should jump. We move from jumping to running. Turn off, click on the transition, turn off has exit time, and we do that when we should run. Okay, so now we have ways to get to all of our different different transitions, different states. So So now we need to decide programmatically, when should we jump? Well, we already decided that we jump when we hit the space bar, right? But when do we transition back? So let's go look at the code. So where's our jump? Our jump was down here. So here's the space bar. So at the very least, we know that if we hit the space bar, we want to say this dot anim dot set trigger, and the trigger we're going to set is going to be should jump. Okay, so that's the easy part. We hit space bar, we should jump. So let's go see that just to show that that's working. But then we need to think about how do we transition back to the other appropriate situations. Space bar, there's jump. Oh man. That's kind of creepy looking. So what we're going to do is I think we can have it hold that second part of the animation, because we don't actually want that guy to repeat. We really want him to, if you think about how Mario works, he jumps and just his arm is up, right? And that's how he hits the little question mark boxes and stuff. All right, so we'll go back to our animator. And let's click on, here's the baby jumping. That's the speed. I think we actually need to click on the animation itself. So here's this is the jumping animation, right? Yep, jumping. So I'm going to turn loop time off for this guy. Okay, so now he jumps once. Now we really want that thing to the hand to stay up. Now what's interesting here is I think we can turn off maybe has exit time. We go back into the animator. I mean, I don't think it looks horrible the way it currently is. I'm going to turn off fixed duration. See if that looks different. And it transitions to it a little funny, and then also doesn't really have a real benefit. I suppose we can, because it's only one frame, we could slow the speed way down to like 0.001. No, we never even get to the next thing. We'll leave it at 1 and just move on with life. If you want your animations to be pixel perfect, you can mess around with it. All right, so call that good enough. Now, notice as soon as I let go of that space bar, the baby started idling again. If I'm in the air and I start moving, the baby starts running. If we go look at the code and see why it's transitioning back to idle or why it's transitioning back to the other ones, it has to do with all these other if statements. Something is all inside of our update. We are moving between animations every single time, aren't we? So if the right or left arrow was just let go of, we move to should idle. If the Now we're in the else. So this guy always happens if if the other thing didn't happen. Now we're asking the question, if we are moving faster than 0, if something caused us to move faster than 0, we should be running. Otherwise, we should be idle. Make sense? So we're always making a transition here. If we go back in here and we ask this question, so our baby isn't really, yeah, see, that's where that else becomes a little bit of a problem here. I'm going to take that else out for a second, because now the fix to have our baby not kind of overlapping idle and run makes our baby not look like he's running when he's actually running. All right, this is what we're going to do. We're going to say should idle if right arrow or left arrow came up. Else if input dot get key down, key code dot right arrow, or input get key down, key code dot left arrow, okay, so if our left arrow or our right arrow were down, then we're going to go ahead and we are going to do this animation thing. So that's where we're going to set the should run. Now, something we're going to do here, though, is I'm going to create a private variable in here. We're going to create a flag called isRunning. This guy's going to start off as false. It's going to be a Boolean. Okay. Now what we're going to say is if either the right arrow was pressed or the left arrow is down. So if either one of those is true, inside here, actually, let's go ahead and do it on the, we can put it inside here instead of making a more complex and up there. So then I'll ask the question, if this dot is running, we're going to put a not on that. If we're not already running, only under that circumstance should we start the animation. That way we don't actually bog down our animator by setting a trigger that we know is already set. And when we do that, we're going to set this dot is running equal to true. Similarly, if we've lifted up right arrow or left arrow, we're going to set this dot is running to false. That's going to turn off whether or not we are internally remembering we're running. All right, and now we can do something similar in here. When should we do this? We should only do this if this dot is running. If we're currently running, then go ahead and transition to idle. That way we're only playing that transition one time. So if we let go of the right arrow or let go of the left arrow when we're currently running, then we'll stop running and idle. Otherwise, if we just let go of them and we weren't running, we're not going to go back to idle because we're in another animation, probably already idle. Else, if we've pressed the right arrow or pressed the left arrow during this frame, because this is inside of update, so this is happening once per frame, then if we were not already running, we're going to start running. Now, in those situations, we're also going to do this add force stuff. So regardless of whether or not we're currently running, I'm going to move my add force inside of my function for whether or not right arrow or left arrow is currently down. But I'll only actually transition animations if we're not currently running. Because what were we seeing? When we saw the baby was kind of stutter stepping, what was actually happening? He was starting his run animation, but we turned off the has exit time. So the next frame occurred and said, play the run animation. Trigger the run animation before he finished his previous one. So it reset that animation. So that's why he was kind of stuttering as he moved along. So now we're only going to trigger these animations when we're going to try to control it as much as we can in code. Now again, one thing to keep in mind though is whenever we have an if statement, that translates into a performance loss. Now don't interpret that as being a problem, but do interpret that as something we do need to be aware of. If you're asking 5 million questions, just like in real life, things will get slow, right? Because you're having to answer a whole bunch of stuff as you go along. But in this case, these questions are relatively important to give us some sort of movement behavior that we deem as reasonable. Okay. Let's see, and then we have the couple different choices we can make here. So right now we're saying if the key was lifted, go to idle if necessary. If the key was pressed, go during this frame. Go to run if necessary. Regardless, do this this movement thing. Now, secondarily, so we only do this code if the right arrow or left arrow is currently down on this frame. So now we have to ask the question behavior-wise. Do we want to be able to jump while we're running? Probably. As Mario is running through the world and you hit jump, he jumps while he's still running. Okay, so that means that this code, should we jump, should be independent of the if statement above. We want both of these things to be able to occur. We don't want to throw it inside of an else where only if he's not idle or only if he's not running can he jump. That means he has to be, actually then in that case he would never get called. So we would have to get creative with it in that case. So we're adding a completely separate question here. It says, look, if during this frame you also press the space bar, even if you're also pressing one of the arrows, if you've also pressed the space bar, we're going to go ahead and have you jump with our current jump power. And we'll add a force in the upwards direction. Okay, so let's see how this guy looks now. Our baby is not moving. Start the run, otherwise get the movement. Oh, interesting. Okay, so right now, what's happening to the baby? Baby is, let's think about what's the, if I try to move to the right, he does start running. That animation looks good, but he's not moving. Move to the left. Baby's running, but he's not moving. So what's the issue? My first if statement in there says if either the left or the right arrow key is currently up. So in this frame, right now, I'm not trying to do anything. I'm going to start trying to run to the right. So right now, my right arrow key is down. But what's my left arrow key doing on the very next frame? It's up. So I'm setting the velocity back to 0. That makes sense? So when I set the velocity back to 0, because I have this as an OR, if either the left or the right key is up. So right now I'm holding the right key down, which is triggering that animation. On the very next frame, my left key is currently up. Therefore, it's setting the velocity to 0. And this is happening, in fractions of a second. So I really need to set the stop thing to say if the key is up, and we need to be able to ask the question, is he currently running? Well, in this case, he is currently running. So now we need to think about, well, what happens? We're responding to this right and left arrow stuff. Just for the sake of argument here, I'm going to go ahead and I'm going to cut this top if statement. That's for the get up for the left and the right arrow. So I'm just going to cut it so I can bring it back if I need to. Now we're asking the question if the arrow is down, if either of those arrows are down. If either of those arrows are down, we're going to do this should run stuff. The else of that, though, says if I'm in this else, that means that neither of those arrows are down. Which means that both arrows must be up. Which means that if I am currently running, go ahead and stop running. And then I'll get rid of this else here. Same exact code, we just moved the logic in a different place because we want our guy to actually be able to move. Now, interesting there. Baby starts running, but it's not detecting that my key is pressed. What does that tell us about the nature of this script or this if statement? When I ask this question right now, if right arrow is down or left arrow is down, what's the behavior of that? Does that mean if this is happening 60 frames a second, let's say, I think this is probably happening faster than that, but let's just say 60. If this is happening 60 frames a second, is this executing the code inside of here every single time through? Is it trying to get to this code every single time? Or is it only if I push the right key or the left arrow down during that frame? It's reactive to the actual movement of pressing it down. not the fact that it's currently down. It's a static event. So if during that exact frame, I press the right arrow down or press the left arrow down, I want to move. I'm going to cut this else. We'll save this. And my baby's not moving again. I would have expected it to move that time. This part is happening. This part should always happen. But this is only on the right arrow down and the left arrow down. So we're not building up a force. So since we saw that this guy only happens once, only if the right arrow or the left arrow was pressed down during that phase, that's when we transition to our runs. I always want to do my movement stuff in update. So the question we're asking here has everything to do with animation. Should I look like I'm animating? If I look like I'm animating, I want to animate. Okay. Or if I look like I'm running, I want to animate. Always try to move. Jump if you're supposed to jump. Just see it real quick. And then homework assignment for Tuesday. So now he's moving again, right? And we can hit the brakes on him. And we do need to put an else in there real quick for the, well, I'll let you do it, to move back to the idle animation. Now, for your homework, though, add to your project, bring it up to date with this, but then make it so that the baby can't double jump. So take what we've learned so far, and you'll probably need to do something with a flag variable to make it so that the baby can't keep jumping if he's currently jumping. Make sense? All right, questions, comments, concerns, bribes. All right, don't forget chapel 9:30. You're invited to come to the front row if you'd like. Also, hackathon people, we've got 2 of you in here. You guys are all in this, both in the Slack channel. I posted my ideas in there initially. If you will, respond to those. And then if you have any of your own ideas, let's do that. So we have fodder to chat about. Remember, we leave tomorrow, 5 p.m. Circle Drive. I think I posted in Slack too, the department is going to pay for your dinner in Chicago both ways. So I don't know that you'll need money, but I guess if we stop at a gas station or something like that and you want a soda, I don't know, I'll probably pay for that too. We'll just expense it all, but you know, bring a couple of dollars in case you need something for something and I'm not standing there, but I'll try to do the best to take care of you whenever we have that opportunity. It's the least I can do since you have to deal with my mom for a night. Or if you're coming to coffee that morning, you have to deal with her at breakfast. And this is all still being recorded.